Today we're going to be working on Leetcode question number 304. Range sum query 2D immutable. We did do a similar question where we had an array and we did implement these two functions. But this time it's a 2D array. So given 2D matrix handle multiple queries of the following type. Calculate the sum of the elements of matrix inside the rectangle defined by the upper left corner and the lower right corner. We're going to be implementing two functions in this NumMatrix class. One is NumMatrix, which is going to initialize the object with the integer matrix, and the other one is the sumRegion. We're gonna be given row 1 column 1 where we which will be the starting point of the square we're gonna be adding, and the ending point of that square is gonna be the row 2 column 2. Return the sum of the elements of matrix inside the rectangle defined by the upper left corner and the lower left corner. The thing is that we need to implement an algorithm where we can do the sumRegion in constant time. Okay. Nice. Okay, here's an example where this is the initialization matrix. The sumRegion is 5, 6. I'm sorry. The matrix is this one, all of it, up to this point. This is the matrix, and here are these are the coordinates where we need to sum, which is gonna turn out to be this green, blue, and red matrices, and these are their sums. The way we're gonna be doing it is very similar to the previous question. We're gonna have a global variable, which can be reached by both of our functions. We're gonna call it let's call it a DP matrix. So and we gonna have a sanity check here, like if the matrix is like the length is equal to 0, or the row is if the column is 0, row is 0, or the matrix itself is null. We're gonna say that if the matrix is equal to null, or matrix dot length is equal to 0, or matrix number of column is equal to 0, right? In all of these cases, we're just gonna return. Okay, so otherwise we're gonna initialize it. The way we're gonna be keeping the elements in the DP, that would be the way we're gonna be retrieving the answer. So whichever algorithm we use in order to save the values in the DP, we're gonna be using a very similar one in order to get the sumRegion between those coordinates. Okay, so we're gonna initialize our DP array, which is gonna be new int, and the size of that is gonna be equal to m+1 and n+1. Okay, so once we initialize it, everything is 0, right? So we're gonna start with that everything is 0, right? Now we iterate through the matrix for int I equals to 1, I is less than equal to mi plus plus. Okay, one other thing is that we forgot to initialize the m and m. So our m is basically the number of rows and our n is equal to the number of columns. Okay, so over here we're just iterating through the matrix and the algorithm, which the main algorithm or main formula we're going to be using in order to save the values in the DP is that if you are at an ij, what you're going to be doing here is to take a value above it plus a value before it, like on the value on the left, and then subtract the value diagonal to it, like top left, and add the value of the current value of the matrix, like sorry, again the diagonal value, because we are one above it, like wherever, if it is m and n, we are filling up m plus 1 and n plus 1. So value of the matrix at diagonal, I minus 1, j minus 1 on the top left. So that would be the formula we're going to be using, and we're going to be using very similar formula in order to retrieve this value. Okay, so once we are here, all we have to check is what is the minimum and what is the maximum, right, in order to like what is the minimum in the rows and what is the minimum in the columns. So we're gonna call it I min is gonna be math dot min inside the row 1 and row 2, right? Okay, and then what would be the maximum is gonna be int I max is gonna be math dot max between the row 1 and row 2. Similarly, j min is gonna be equal to math dot min into column 1 column 2, and j max is gonna be equal to math dot max of column 1 and then column 2. This is to avoid the situation where like we have the basically this is about the situation where the row like the coordinates given to us are like we have a coordinate where which is the row 2 and the column 2 coordinate is before the row 1 and the column 1 coordinate. Okay, and now the thing is that we're gonna be using very similar one where we, in order to return the value, basically we're gonna say that it is the dp of I max plus 1 and I j max plus 1, and then we're gonna subtract two values and from it, one before it and one above it. I'm sorry, we're gonna, in order to calculate that, what we're gonna be doing is, yes, one before it and one above it, minus dp of I max plus 1, and then j max would be a value which is gonna be 1 before it, negative dp of this time I max and then j max plus 1. This would be a value which is 1 above it. Okay, After these two, we're gonna say that actually there's one more thing. So it's not just this one. What we need to do here is to, when we are using the other one, instead of doing that, not one above or one below it, one above or one to the left to it, it's gonna be the same coordinate on the row side once, and then the j min. Similarly I min, because we need to return the value before, like the, okay, let me write down the formula first. Okay, I min and this one, and then the last thing we need to add into it is the dp of I min and j min. So very similar to this one, if we are trying to calculate like the red square here, 201 101 2030, we're gonna be returning the I max plus 1 and j max plus 1, and then we're gonna subtracting the element which is dp of I max plus 1 and j min. So we have to remove so one coordinate, sorry, once we have to use the column where we are using the minimum value, and once we have to use the row where we're going to be using the minimum row, and then we're going to be adding the jp of I min plus j min. It is very similar to this formula, not exactly the same, because we are going to be calculating everything with the dp array, not using anything in the matrix. Okay, matrix. Okay, we didn't say length. Looking good. And it passes all the test cases.